Hello, everybody. I'm John Moore. I'm speaking to you from the Institute for Earth Observations, the New Jersey Globe Partnership, and we're in just north of Philadelphia. So today we're happy that you're joining us. We have a couple of things we're going to cover today, but the real feature of today is looking at some students from Medford Memorial School and some things that emerged due to COVID. So it fits into looking at the Globe Mission Earth campaign that we do here, and some things that go along with COVID. So we hope you enjoy it today. I'm going to start out, and then I'll be introducing you to Vicky Gorman, who is the Presidential Award winner for New Jersey in 2015 and teaches 7th grade at Medford Memorial School in Medford, New Jersey. And then we're going to hear from the students from her class. So we're going to do all those things. So hang on, and we're going to get started right now. So as you can see, we're calling it Investigating the Earth System. One of the things, so my part of this, first couple of minutes, just talk about things that have been floating around over my years and seeing how things have evolved or changed. And looking at Earth system or Earth system science, being a person as an environmental scientist, and I taught that for 28 years, and working with NASA for a long part of that time. There are people that mostly in this group, it's not news, that NASA, NSF, and NOAA talk about Earth as a system. One of the things is that schools don't look at that. It's very difficult to find a class on Earth system science. So there's some of the things that we want to talk about. So right now, I think we're gathering some momentum, and I believe that the time is really good for all of us, particularly those of you that are on this webinar, to think about how you can contribute to that. Okay, there we go. So these are the talking points I'm going to go through very quickly, and these are some things that kind of set the groundwork. A lot of these are not new. Some of them, many people have been working on these with me for many, many years. I'm starting to bring things together to get an idea and some concepts and how to move things forward, both for us as scientists and also how we relate to schools. So first thing I want to say, first bullet, is talking about the Globe Satellite Education Team, or what I call it GSET, or what I really say, if you're talking to me face to face, as you are now, is get set for the new thing. So there's a lot of satellite people online. There's a lot of satellite people that either work with satellites or remote sensing or computer visualizations that, I have this fantastic network that I've put together over 35 years, and all of you are among that. And there are people that have interest or work directly with satellites, yet there never could seem to be one group that could get that going and have it show up in a meaningful way in schools. We see each other at Globe Mission Earth events, and at the Globe events is about 2 times a year that we get together and actually see each other. Then everybody has their jobs. So this attempt, which I unleashed on Earth Day, which was the 50th anniversary of Earth Day, and it was also the 25th anniversary of Globe, hoping to launch us as a community into a group where we look at the role of satellites in our public schools. I write an article once a month. There is a Satellite Education Association that's been around for 34 years. And I write a piece for that's called John's Journey each month. And one of the things I say there is, you can teach all things by satellites. So Miss Gorman, who you'll be hearing from next, it took me a couple years to convince her of that, but I think she's on the team now. So that's what that's about. Next bullet talks about science versus science education. So you look around, and my experience is there's a science agenda for the United States. It consists of Congress, National Academy of Science, the White House, and the National Science Foundation, and other federal agencies. So when I served as an Einstein Fellow in Washington, D.C., I was working with all those science people and all those organizations. So they have a plan, they know what they're working towards. They all have different roles and responsibilities of pushing that agenda. And then you go over and talk about into the Department of Education and talk about what science education looks like in our schools. And they don't match very well, in my opinion. Um, the point here that we kind of laying under all this and the satellite education team is, can science education begin to reflect what the science agenda is, what the scientists in the US are working on? So when we talk about career opportunities, career paths, creating diversity, offering opportunities, first of all, the students have to know about it. So I worked in the Directorate of Geosciences. And one of the things they always say is, well, why isn't anybody in geosciences? And we have opportunities for enhancing diversity in geosciences as part of what I did. And my comment to them was, well, where would any student ever hear about geosciences? In fact, most adults don't even fully understand or ever heard of what geoscience is. So that's the part about getting some people together, and this kind of like a underlying objective that we want to put into this group. The next you see there is GeoSTEM. So we come up with this a few years ago, written several articles about this, and it stands for Looking at the Geosciences in STEM Education. Now this is where I got to that point. In the geosciences, by its very nature, it's very multidisciplinary. There's maybe 20, 25 different disciplines. Almost everything can fit into a geoscience definition: physics, chemistry, biology, all the traditional things that you would see in our schools. And when we talk about STEM education, if we talk about STEM education as the SNTNENM, not one of the two or three or four, but all STNENMs, the geosciences have maybe an unfair advantage because we have satellites, airplanes, ships, remote sensors, go on and all the disciplines. So we have all the technology, the engineering that supports that goes without saying, and the mathematics, of course, is the language that supports all the engineering. So the geosciences and GeoSTEM is truly a true STEM initiative. Now you couple that with the interest of students these days in things like climate and the ecosystems and energy and water quality and conservation. My experience of teaching high school for 28 years, I know that they're interested in it. They need the opportunity to be exposed to that. By the way, the little sub-bullets there are the different divisions in NSF, Directorate of Geosciences. So geosciences, there's some discussion on what NSF calls it versus AGI. And so there's a little bit of mixed match in some of the definitions, but have gone with and stick with NSF's version or vision for the geosciences. The next bullet quickly is something that I thought about for years and years and years, and people would ask me what I do. They'd ask my wife what I did, and she would say, I don't know what he does. So we say, well, it's something with satellites and it's the environment and looking at data. So one day, not too long ago, it hit me, a simple 3-word phrase, A cubed, we refer to it. It's all about acquiring data, analyzing the data, and then applying the data. And that doesn't necessarily have to be in that order. When we're talking about pre-college students, it might be with application first. Geez, I wonder about climate. What is the truth about that? And what is this? And how's this affecting that? And who's saying what? How do I know how to believe? Well, then you go back, acquire the data, analyze the data, and then you can apply it. And I think you'll see that today in a few minutes. The next thing that we use as a driving force here is, you can read it, just call it the SEAS model, space to earth, earth to space. In other words, for the first time in the last, maybe it's getting to be a decade old now, but we have the abilities, and students have the ability to look at Earth from space using remote sensing and satellites, but also on the ground, like through the traditional GLOBE protocols, where we can go out in the field. So it's both the on the ground kind of protocols and what I call traditional environmental or earth sciences, but now students have ability to gain the data from space. And we should be using that in our schools, using the highest technology. Another thing that I had to talk about for 28 years is career technical education. Lo and behold, after all this time, it's now in vogue. So what's the difference to some people that are not familiar with that? Well, it comes down to, as I say, their proficiency-based education. So it's not necessarily about the standards. It's not about passing tests. You have to do all that kind of stuff. But what is really important there is that you know how to do something and you can demonstrate it. Now, one difference between CTE education curriculum-wise for the educators online is that if you look at a curriculum, generally it's very linear or scaffolded. It moves up in one direction from the bottom to the top. CTE education is really forms in a cyclical motion that goes around and round. You present a skill, and you think about this as adults, we do it. Well, you want to learn how to bake a cake. Well, first time, you read the ingredients, it might mess up here or there, cake doesn't come out so good. Well, go try it again. Then you get your basic cake, and then they say, well, let's try this. And you keep adding to it until maybe someday you're a chef. So if you use that as an analogy to the science part or to the technology part, that's what we're looking at in technology education. So when the students are done in a career technical high school, they are prepared academically as well as they have skill sets to bring on to college or go into the workforce. Finally, this is my last slide, and Max is in the center there. He's behind me, working with me. Max is going to be a senior in high school, so don't think this stuff is for PhDs only. So it says coming soon in 2021. Now, my Globe Mission Earth family know this, and anybody that knows me personally knows I'm all about satellites, and I've been working literally for 10 years on CubeSat idea. Well, Max is in here spending his time with me, and he is building, as we speak, the CubeSat model. We, as it said, our plan is to launch that through Globe Mission Earth, so stay tuned for that in the coming school year. And what you see him working on, I'll use my screen, this is Max right here. He designed, built, wrote all the coding for this, and he's going to be a senior teachers out there, a senior in high school, not college, senior in high school, put all this together, is doing all the coding. These are some people back at his class at BCIT. This is a home built or a kit drone. These are 3D printed parts that we're learning how to hook the CubeSat to the drone. And the reason that's important is because people can build real CubeSats, but unless you have a friend at NASA or a lot of money, you're never going to get it in space. Yet, this is an upcoming career for these young people that will be speaking today. If you're in middle school or even grade school, in your future, this will be common knowledge. So the thing with career technical education, use what you can now and do the best you can. And then when you're ready to go to college, the way it is now, where college students are building true satellites, true CubeSats, and putting it in space. And where it loops back is you're creating your own acquire. Now, I think that's pretty cool. So we're going to move on to introduce you to Vicky. Let me get this, make sure I'm doing this right. Okay, are you seeing Vicky's PowerPoint right now? Or
yes, it's not in present mode, but before you present it, make sure you click on the first slide. Otherwise, it's going to present. Yeah, okay. And now hit present up at the top. You see present in the right hand to the left of share? Yep.
Okay. Is that where we are? Is that the right place? Are you seeing it now?
No.
But I have two screens.
I am not seeing it.
Okay. Share? No.
No.
Present. Why is it going there? Hold on. Excuse me, folks, while we deal with the technology here. Well, it's showing on my other screen. So let's see.
Well, all you have to do is share that other screen. Did you share?
Or drag it from that screen to your screen.
Right. You can drag it from one to the other, or you can unshare and then.
Yes.
Yeah, but we need it at the beginning.
Okay. So let me try this again. Hold on.
Well, all you have to
Well,
do
you
is, oh, go ahead.
You're right, Vicky. Just do the little arrow at the bottom.
Right.
Mm-hmm.
See down there, John? Well, you can do it that way, or yeah, that's fine.
Okay,
Just,
taking this slow way.
or you can see where it says slide 70, just click there. No, yeah, click on the arrow and then from the beginning or wherever it says. I can't see it, it's so small.
Where is it?
Yeah, slide it up.
That's it.
Yep.
And then number 1. There you go.
See, students and adults, you're never too old to keep learning stuff. The one piece of advice I can give you is you just notice that I don't get upset. Now, Vicky's probably holding her breath right now, but see, I'm cool as a cucumber. So you just got to roll with it. Okay, so Miss Vicky Gorman, 7th grade teacher. She has too many things to her name. It would take the whole webinar to say what she's accomplished. Maybe her highest award is she's a presidential awardee in science for the state of New Jersey. More important than that, she loves satellites and she's my good friend. So Vicky and students, go ahead and I become the slide advancer now. It's all yours.
Okay, thanks, John. Go ahead and mute yourself, because I don't want to hear any more comments about the fact that I'm going crazy. I was very calm, although I was grumbling under my breath when you couldn't get back to the slide. That's true. Okay, so hi guys, I'm Vicky Gorman. I just want to give you a quick, I know most of you, but just a quick summary of how I got here today on a call with you. My first career, I was in the U.S. Army, and I was in the combat arms years and years ago when women were first admitted to the combat arms. None of this stuff now in the 2000s and 2010s. I was way back when, and I was one of the first female battery commanders in the combat arms. My specialty became nuclear weapons. I lived in Europe for 8 years, and most importantly, I guess, is that I met my husband. Then my second career, I have an international horse business. I still have the business, although it's scaled down quite a bit. And we had horses in Europe. We flew them back here to the States, and that yellow brand is the brand of the German breed Hanoverian, and that is the breed I specialize in. But this all leads to me becoming a middle school teacher about 13 years ago. I will be starting my 13th year in September. I teach in Medford, New Jersey. I have 4 sections of 7th grade, a challenge class with 20 7th and 8th graders. Some of you know those guys. Those are my CSEPers. But they're not with me today. I have my regular 7th grade kitty widgets, as I call them. And I'm big into STEM, satellites, and globe. And actually, it didn't take me that long for John to convince me that satellites were the way to go. What it took me a long time was to see his vision for STEM. And I'll talk about that very briefly at the end. Okay, John. Okay, there we go. Late afternoon on Friday, March 13th, 2020, New Jersey shut down schools due to COVID-19. It was about 4:30 in the afternoon. The students had left. Most of the teachers had left. I was in school and I saw it come across the wire. Next. We had lots of questions, of course. All teachers all across the country had questions. How is this going to work? How is this going to look? Most of us thought that this was only going to be a short-term thing. We had a 3-week pandemic curriculum that was probably never expected to be used. It was very basic. It was very boring. It wasn't comprehensive. But we thought 3 weeks, and then teachers had to make a week of almost busy work for the students. We figured we'd go into spring break and then we'd be back at school. Of course, we all know how that went. So rather than panic about it, next slide, I saw this as a unique opportunity to see how students react to home learning with limited teacher and peer support. Now, as a teacher, you know, you have these students who come in and tell you they didn't do their homework, or what I call home learning, because I don't like them to think of it as busy work. And you really don't know what's going on at home. And it wasn't until this pandemic and remote learning that I started to realize the complex issues that students have to deal with at home, such as language barriers, you know, the parents speak maybe their native tongue, money issues, having availability of a computer, even having an internet. And I teach in a fairly affluent community, but we still had all those issues as well. So I wanted to see what would happen. And peer support, we do most of our work in science class in small cooperative learning groups. And the students are in those groups for the entire year, and they get used to dealing with those students and having feedback from those students and support from those students. Next slide. So I decided to do an experiment, although I can't really call it an experiment because then I would get in trouble because, you know, I'm working with kids. This is just simply a reflection project by a teacher. But I wanted to do something just to see how the students would respond. So I had a project, and these were the questions that I wanted to answer. How would students deal with a challenging long-term research project? Now, most of the students had never done a research project, let alone a long-term research project, and let alone a challenging long-term research project. But I figured I'd throw all those in together to see what would happen. I was curious as to what topics they would choose. As you can see on the right, that's the first page of the 26-page research packet, which I didn't give all at once. Students got the update each day. They got an additional page to the packet because I didn't want to overwhelm them or have them work ahead. But what topics would they choose out of Earth's dynamic systems? Could students add a layer to their critical thinking? I had them add a human component to this project. What would be the reaction to presenting the research live using Google Slides via Google Meet? All students had to sign up for a 15-minute slot and then join me and give their 7-minute presentation and then get their feedback right away. And the real question is, should I pursue turning this into a comprehensive STEM exercise for future students? And by STEM exercise, I mean incorporating satellite data, because I didn't make that a huge criteria on this first project, and also doing some engineering projects with maybe building satellites and that sort of thing. Next slide. Out of 90 students that I had in all my 7th grade, I identified 16 of them that would be good to present. Now, these are students that are all different backgrounds, okay? Regular ed students, special ed students, they were A, B, and C students. It didn't matter what they had performed like before. If they did well on this particular project, it was reflected in their grade and reflected in my desire to have them present should we be able to put a webinar together like we did today. Of those 16, I picked 9, the top 9 students, and that also, well, the top 9 students which broke down to 3 presenters, 1 moderator, and then students who have some reflection about the project. Not all 9 students were able to make the webinar because of prior vacation plans and other things, but I think we have a good representation of a real cross-section of my students. Next slide. So without further ado, I'm going to turn this over to the students, and our moderator for today is Trinity Vital, and she's going to take over. Trinity, you can unmute, and please remember to speak up with that lovely voice of yours.
Thank you, Norman. Hello, everyone. It's a pleasure to be here today. My name is Trinity Vital. I'm currently 13 years old, and as of the time of my presentation, I was in 7th grade, but now I'm going into 8th grade, and in my free time, I enjoy participating in STEM activities, listening to music, and reading dystopian books, as well as art projects, Girl Scouts, horseback riding, online gaming with my friends, and fashion and home design. You can move on to the next slide, please. So before we get into the research projects, we're going to get the live reaction of some students on the line for their remote learning. So we have Faith Kim and Nola Podolsky, who can please unmute to answer some questions, and we can go on to the next slide. So the first question I'm going to ask for Faith first. How would you describe the remote learning experience?
Hi, my name is Faith and I'm 13 and I'm going into 8th grade, and my research topic was polyphasic sleeping, and I'm really thankful to have this opportunity. And I would describe the remote learning experience as kind of different from normal school assignments because it relied more on me being independent and relying only on myself. And there is no one like just saying, oh, you should fix this or you should do this better. So I kind of had to critique myself.
Okay, and Nola can answer the question too now.
Hello, I'm Nola and I'm 13. And it was different and it was sort of tough, but we adapted to it as time went on because we had to do a third of the school year online. So it was definitely a good experience to have working alone without people influencing us all day.
You can move on to the next slide. The next question I'm going to have Nola answer first, and is, how is the research project different from your normal school assignments and projects?
Well, of course it was online, so that was very different. But all throughout the school year, we were working with the people in our group, and they would fix some parts for us, or we would all be working together, helping each other. But with this, I had to do my research alone and do my project alone, which was a good experience, and it was also hard, but it was good to do for my learning experience.
And Faith, what are your thoughts on this?
Well, like Nola said, we used to work in groups, which we called tribes, and now we didn't. So it was really independent. And also this, we got to choose our own topic. So we didn't really follow the normal curriculum. And I guess it just gave us more freedom to like choose what we wanted to learn about.
You can go on to the next slide. And Faith can answer this one first. It is, why is it interesting to choose a topic about the Earth being a system of systems?
Well, it was interesting to choose a topic about that because I kind of learned about how everything like works together to produce like the trees, rainforests, plankton, things like that.
And Nola?
I liked learning about it because it's around us every day, and I think people should know what's going on around them because nobody really thinks about the Earth being a system of systems, but learning about this was different in a way because I saw things that I would usually ignore every day.
You can move on to the next slide, please. And Faith can answer this one first again. Specifically, which part of the research project was most difficult for you and why?
Probably the part that was most difficult for me was the actual research because my topic was really not well studied or researched about. So it was really hard to find good information that could relate to my question.
So Nola, what was most difficult for you?
It was difficult, like making my slides on my research project more condensed and putting them into bullet form because I had so much information from the research online that I was going to present, but I could only present a certain amount. So it was hard to figure what should I present and what should I leave out.
Next slide, please. So Nola, what did you personally gain from the research project experience?
Like I said before, learning independently about a topic that I chose myself was much different because the curriculum is usually the teacher teaching and the kids working together to learn. But COVID-19 and working at home made it all independent, which was a good experience.
So Faith, what did you learn?
Well, I actually learned a lot about myself. I kind of learned that I was more of a procrastinator, which I'm trying to work on. And I really like learning independently because I don't have to like listen to other people's opinions and I can just have freedom to do like whatever I want in the project. And I also like choosing my own topic.
Next slide. So now we're going to talk about the research project, and we had a few basic guidelines, which includes our topic had to be related to the Earth being a system of systems or spheres. And as you can see on the right, we have the biosphere, geosphere, atmosphere, hydrosphere, and within the hydrosphere, the cryosphere. We also had to have a human connection to relate the project back to how it affects us, as well as we had to format our topic into a research question. And at the bottom in yellow, you can see my research question, which was what positive and negative effects do tectonic plates have on our everyday lives? And finally, we had to organize our presentation into a Google slideshow, and we were allowed to choose our topics so we were interested in what we were learning. You can move on. We also had a timeline for our research project in which we were able to choose our topic and create our research question across approximately 5 days of a school week. Then we moved on to take our topic and write handwritten notes in our journals or on loose pieces of paper for about 1 to 2 days a week for 6 days total. Next, we used our notes to create an outline in a bullet form with the same strategy of about 1 to 2 days a week for a total of 5 days. Then we took our outline and bullets and created a presentation with a template that we were given by our science teacher, Ms. Gorman. And finally, we rehearsed our presentations and got ready to present them live via Google Meet for our teacher in a private meeting. Next slide. We also had some more specific guidelines, which includes a helpful tips page, which you can see on the right, which includes not only tips and tricks for ways to set up our project and make it easier for us, but also time references for about how long we should spend on each section to ensure that we complete it thoroughly. And as you can see it starts on number 34 because it was a continuous string of notes and tips that were being added to each day. We can move on. We also had something called an AOD, or Assignment of the Day quiz, which was a daily quiz that tested us not on the comprehension of the knowledge, but the fact that we had completed our assignment for the day and that we knew what material was taught to us. And you can move on. Now we're going to hear from some of our junior scientists, starting off with Elena Bonfrisco with her presentation, Earthquakes Around the World.
Hi, my name is Elena Bonfrisco, and I'm here to talk to you about what are earthquakes and how they affect people around the planet. Next slide, please. So let's get into a little about myself. I am 13 years old and I'm going to 8th grade. I have a cat and a dog. My dog's name is Bear and my cat's name is Maggie. My favorite hobbies are hockey and lacrosse. The reason why I chose the topic earthquakes today was because there are not many around here, and if we did have a major earthquake, I know I would be unprepared. Next slide, please. So for today's presentation, we have what is an earthquake? Earth's outermost layer. Movements in Earth's outermost layer. What causes damage? Japan, Italy, Turkey, and San Francisco, California, USA. Next slide, please. So what is an earthquake? An earthquake is an intense shaking of the Earth's surface. Next slide, please. The shaking is caused by Earth's outermost layer, the lithosphere. The lithosphere is made of the crust and the uppermost mantle. Next slide, please. The lithosphere is cracked up, and that's what we call the tectonic plates. They are kind of like cracks on an eggshell, and they all move in different directions, different and same directions. Next slide, please. Here is an image of what happens when tension is lost between two earthquakes and they move past each other. Next slide, please. When they move past each other, they create a focus, and that's the place where earthquakes originate. Next slide, please. If you go directly above the focus, you will find the epicenter, and that's where scientists find where the earthquake originates on land. Next slide, please. Next slide, please. So what causes damage? Seismic waves. There's 3 different types of seismic waves, and there's 2 different types of surface waves. The first seismic wave is the P wave or primary wave. This is the fastest wave, and the black dot you see on the screen is what is the piece of land. the piece of land. The P wave compresses that piece of land. Next slide, please. The second type of wave is the S wave, or secondary wave, or shear wave. Okay, shear wave. It goes up and down, and it brings the piece of land up and down. Next slide, please. The third type is a surface wave, and it brings the piece of land back and forth. As you can do, the lines on the right side of the end of the diagram are they are larger on the top and get smaller on the bottom. That's because surface waves do not go through the surface. They're the most damage is on the top. Next slide, please. And the rayleigh wave, the last wave, takes a piece of land, and it's the most dangerous wave. It moves it around. And the circle arrows, you can see, like I was explaining the last slide, that they're bigger on the top because that's where they hit more. Next slide, please. So what do seismic wave variation cause? What they cause are landslides, building topplings, ground displacement, avalanches, and tsunamis. These all won't happen during an earthquake. It depends on where you live. So if you live in the mountains, you're more likely to have an avalanche or landslide versus when you're in a city, for instance, New York, you'll have a building toppling and ground displacement. Next slide, please. So let's go to Japan. Let's see our earthquakes in action. On March 11, 2011, an earthquake and tsunami struck. The magnitude was 9.8. And magnitude is what we measure earthquakes from 0 to 10 on the Richter scale. The epicenter was in the ocean. It was 80 miles east of the city Sendai Miyagi on the island Honshu. Sendai is the city and Miyagi is the district. It was on 2:46 p.m. Friday. Next slide, please. This is an image of the waves, not the seismic waves, these are the tsunami waves. The little triangles you see are the buoys, and scientists, when they were looking at this, the buoys rose a couple centimeters, so that's how they could tell how dangerous the waves are. And the black dot, I can't really see that. The black dot is near the NOAA sign, NOAA sign, sorry, is where the buoys were highest, and orange, where the bottom of the picture is where they were the lowest. Next slide, please. Japan, thousands went missing during this, so it was hard to find people due to all aftershocks. A ship went missing, but was later found at sea. Rescue teams saved all injured or unhurt people. What they did today, what they did today was they learned how to stock food in emergency food supply locations, and they raised buildings so water cannot flood them out. Next slide, please. Let's go to Italy. On December 28, 1908, an earthquake and tsunami struck. The tsunami is 40 feet in the air. The magnitude was 7.5 on the Richter scale. The epicenter was right on the Strait of Europe. The Strait of Europe, the Strait of Europe separates the island Sicily from Calabria. It destroyed Messina. Italians have not changed the way they live. What they do say, they don't change the way they live, but towns now keep emergency food supply because of this. Next slide, please. This is an image of the destruction of Messina. You see there's a bunch of people, and they're leaving the city because they cannot live there. So what they did was they either A, immigrated to the U.S., or B, they lived into other Italian cities that weren't damaged. Next slide, please. Let's go to Turkey. On October 23rd, 2011, an earthquake struck. The magnitude is 7.2. The epicenter was 10 miles north of the city Ikizan. 570 people were killed. Thousands of structures were destroyed, and it was felt as far away as Jordan and southern Russia. Next slide, please. Here is the image of what was fell on the map. The red dot you see is the epicenter, and that was the most violent spot, and the orange is the severe. The orangish yellow is the very strong, the yellow is strong, and the not the M, oh my god, I'm so sorry. The green is moderate. The earthquake happened between the Eurasian plate and the Arabian plate. Next slide, please. Those two plates hit each other. With the Turkey's Industry of Help and Red Crescent Group, it's a group of people who help injured or unhurt people, join forces to repair damage and help injured or dead people. The people of Turkey today made stabilizers for buildings. So if a dangerous earthquake ever happened like this ever happened again, they will be ready. Next slide, please. Lastly, we have San Francisco, California, USA. On October 17th, 1989, an earthquake struck. This magnitude was 6.9. It was 60 miles south of San Francisco. It was close to the bay. It was not in the bay. It caused 63 deaths and 3,800 injuries. $6 billion in property damages. It increased emergency service and they built better stabilizers and more sturdy foundations. Next slide, please. Here is an image of the destruction, and on the right you see an image of the map, and you see the San Andreas Fault, and you see the Pacific Plate going north, and you see the North American Plate going south. When this earthquake happened, they moved forward, which created the earthquake along the San Andreas Fault. Next slide, please. So for a summary, we must know earthquakes affect people in many different countries. The movement of the outermost layer of Earth causes tectonic plates to get stuck in each other. Earthquakes happen when they thicken or tension is released. If you live near a fault line or tectonic plate boundaries, you have more earthquakes. That's why here in New Jersey we don't have many earthquakes because the closest fault line and tectonic plates have is the Atlantic Plate and the San Andreas Fault Plate, which is all the way from California. It's all the way over in California. Next slide, please. Seismic waves are the cause of the damage, and the damage is from tsunamis, landslides, avalanches, ground displacement, and building toppling. People do die from these things. Each country deals with earthquakes the same in both different ways. Next slide, please. Here are my references. Next slide, please. Here are some more of my references. Thank you so much for listening to my presentation on earthquakes today. If you have any questions, please ask them now.
So if anyone has questions, they can unmute and ask now or type them in the chat box to be read aloud. And thank you so much, Elena. That was great. It's really interesting how different places handle earthquakes so differently.
So hi, I am Owen Sweet, and today we will be talking about what is the relationships between humans and ocean pollution. Next slide. So some stuff about me. I'm 13 and I'm going to be in 8th grade in September. I'm a part of a Boy Scout troop, Troop 20. I golf and I do karate. I really like my school and my teachers. I chose this research question because when I go to the Myrtle Beach every summer, I find trash on the beach and in the water every day, and I wonder, how does that affect us? Today's presentation will be about these 4 topics. So before we get into how humans are affected by ocean pollution, let's see how do humans pollute the ocean. There are 9 main ways of how humans pollute the ocean. Next slide, please. Garbage. One of the greatest impacts on the ocean is plastic garbage. This also includes water bottles and fishing nets. Next slide. Sunscreen and other topicals. Sunscreen and other topicals can affect the chemical makeup of the ocean's water. As you see in the image, As you see in the image, there there are two chlorals. One is healthy and one is bleached. How a chloral gets bleached is by a very big increase in temperature in the water, or the chemical makeup of the water changes. Next slide. Oil seepage. Oil from oil tankers and oil platforms can spill into the ocean, and the outcomes can be disturbing. It can destroy a local ecosystem. It can set fire, like you see in the image, and it can change the water's makeup. Next slide, please. Sewage. Clogged sewage pipes and storms often push sewage into the ocean. Also, hurricanes can cause stress on the sewage pipes. Next slide, please. Agriculture and aquacultural. This is when fertilizers and pesticides, well, agricultural is when we use fertilizers and pesticides to help the farm, but these don't always go into the soil, and some of them are run off into the ocean by like rain or a flood, and these can go into the ocean and change the ocean. And aquacultural is when humans are breeding fish, shellfish, and algae to make food, but this must include them taking animals from a local ecosystem. Next slide, please. Industrial waste. Industrial waste is one of the biggest influences because we are dumping huge amounts of trash out at a time, and it's when industries or factories throw out wasteful items like dirt and gravel, concrete, and scrap. Next slide, please. Eutrophication. This is when chemicals like nitrogen and phosphorus we use on the farm to grow plants, but like agricultural, these can be washed down into the ocean, into a local body of water, and result in an algae bloom. And these algae blooms can use up all the oxygen in the area, and this is a satellite image of what an algae bloom looks like. Next slide, please. Carbon dioxide. When we burn fossil fuels like oil and natural gas, the carbon combines with the oxygen in the air to make CO2, which is carbon dioxide. The CO2 is absorbed by the ocean and mixes with the water to make carbonic acid. Carbonic acid can thin like shells for crabs and local shells and can kill corals off. Like you see in the image, there's carbon dioxide plus water equals carbonic acid. Next slide, please. Noise. Noise can pollute the ocean by interrupting animal calls to migrate and mate. Also, for some animals in the Arctic, like seals and narwhals, this can interrupt them trying to find air pockets so they can breathe. Next slide, please. So, how does ocean pollution affect humans? Ocean pollution affects humans in some of the biggest ways, but there are 3 ways it affects us. 97% of the Earth's water is contained in the ocean. If that were to get contaminated, we're losing a bunch of water from the Earth. And also, 70% of the oxygen we breathe every day is produced by marine plants, like algae. But not all these plants in the ocean produce helpful oxygen. They can produce toxic air. And also, 30% of the CO2 emissions produced by humans are absorbed by the ocean. If we didn't have the ocean, we'd be polluting land, which also would cause climate change, and we would burn. Next slide, please. So, how does ocean pollution affect human health? Ocean pollution has affected our human health in really big ways. Ocean pollution has contaminated our food chain in these steps. As you see, the little fish is contaminated by the oil. The big fish eats the little fish, and then we catch the big fish and we eat it, and we would get sick because it was contaminated. These chemicals can cause us to have health issues. Most affected are by unborn children and newborns. Next slide, please. Ocean pollution has affected our economy in giant ways. They can shut down beaches so we can't relax on them. It can shut down companies like hotel and motel companies along the shore because their main income is from trying to lay on the beach. But if you can't relax on the beach, you're losing that, and that's a big part of their income. And as you see in the image, this is a beach that has been over polluted, that's over the sand dunes. Next slide. Also, it costs the US around $13 billion a year to keep trash off beaches. Imagine what the US could use that money for. Next slide, please. So how does ocean pollution affect trade? Ocean pollution affects trade in huge ways. Trade is our way of getting new ideas, learning new items, and trying to communicate. But there are big influences like gyres. A gyre is a circular current of water that is moving in a circle. But as it is a natural force like gravity, it doesn't stop. And there are 5 main gyres: the North Pacific, the South Pacific, the North Atlantic, the South Atlantic, and the Indian. And as it's a natural force, like I said, it doesn't stop. These are probably still collecting trash right now. But there is one, the Great Pacific Garbage Patch is the biggest garbage patch in the world. It is 3 times the size of France, and it holds between 1.1 to 1.3 trillion pieces of garbage plastic, and that's just plastic, not including all the other items. Next slide. So these big gyres have also influenced trade winds. A trade wind, there are 4 of them. There are 2 outer ones that go from west to east, and the inner ones go from east to west. There are 2 inner ones, both of the inner ones next to the equator, which is the yellow line, go from east to west, and the 2 outer ones go from west to east. As you see, the US and China are the 2 biggest trading partners probably in the world. So if we were to trade with them, we'd take the inner winds and travel there quicker, and we'd take the outer winds to travel back faster. But now that we have this big gyre in the way, it's going to make things a lot more difficult, and we're going to have to use more gas, and we're going to have to go through a lot more. Next slide, please. My summary. There is a definite relationship between humans and ocean pollution. Humans pollute the ocean in the 9 main ways like we saw. Ocean pollution impacts human health, the economy, and trade. And if you go back, please. So if you see any trash on the beach, do your part and pick it up, and you can help stop ocean pollution. Next slide. These are my links and references. Next slide. These are some more. Next. These are more. And next. Next. These are more. I am Mo and Sweet. My contact information is here. Any questions?
So yet again, people can unmute if they have any questions or type it in the chat box. And thank you so much, Owen. That was amazing. I never knew there were so many different ways we were polluting our oceans. So Tracy asked, what can we do as individuals to promote a cleaner, sorry. Okay, moving on. I'm sorry about that.
Wait, I got it.
We have Maddie White with her presentation about climate change and precipitation.
Hi, I am Maddie White, and my presentation is on climate change and its effects on precipitation across the U.S. Next. A few things about me is I enjoy playing sports. I am 13, heading into 8th grade. I enjoy going to the beach and hanging out with my friends. And reasons that this topic interested me is because everything has a chain of connection, whether it's climate change affecting rainfall or even as simple as the soccer ball linked to the whole sport. Next. In today's presentation, you will learn about weather versus climate, climate change, climate, relationship between precipitation and climate change, and a little short summary at the end. Next. First, we're going to talk about weather versus climate. Weather is the state of the atmosphere at a particular time and place. Climate is the average weather of a location over a long period of time, which is usually 30 years. And climate is more, oh, go back please. Climate is more of an expectation, and weather is what you get on that day, which is represented by the image on the right. Next. So we're first going to talk about climate. Two things make up climate: air temperature and precipitation, which is also known as rain, snow, sleet, and hail. On the right, there is a climatograph of McMurdo Station in Antarctica. The blue bars represent precipitation in millimeters. The red line represents temperature in degrees Celsius. By the graph, you can also see that Antarctica is very cold and receives little to no rain. Also by the data, you can tell Antarctica is located in the southern hemisphere because the months March through September, they receive the coldest weather at a low of -26 degrees Celsius, which is also below freezing. So when we have summer, they have winter. But even when they have summer, they still receive weather that is below freezing. The highest it gets is around -3 or -4 degrees Celsius. This graph also represents that Antarctica is a cold desert, and the months represented by the blue bars, they represent 30 years of precipitation climate data. Next slide, please. Next, we're going to start talking about climate change. Climate change is a continuing change in normal weather trends that have characterized the local, national, and global climates. In the image to the right is a temperature anomaly in degrees Celsius. As you can see, there's a line going through the graph, and that line represents 0.0 degrees Celsius, which is also the normal or the average temperature of Earth. Anything below the line shows cooler temperatures, and anything above shows warmer. The basic trend has been a steady increase in temperature over the average. The highest increase is 0.8 degrees Celsius. If the air is hotter, it holds more, which equals more precipitation. Next slide, please. Next, we're going to talk about the relationship between precipitation and climate change. Extreme precipitation events are observed to increase intensity by about 6 to 7% for each degree Celsius of temperature increase. Cold air holds less water, while warmer air holds more water. On the image of the right is the water vapor capacity, and on the very left in little words you see capacity and grams, and that is measured in grams per cubic meter, which also represents density. This graph shows that when the temperature shown at the bottom increases, the amount of water vapor the air can hold also increases. Next slide, please. This is an image that represents average annual rainfall, and if temperatures are increasing all over the globe, then we would expect to find more evaporation and more precipitation all over the globe. Places near the equator, which is around the blue and light blue areas, tend to receive more rain because warmer air holds more water vapor. So if the air near the equator is hotter, it can hold more water vapor. If there's more water vapor in the air, you are going to get more precipitation. But if the temperature of the entire globe is increasing, everywhere will experience more evaporation because in most places, the air will be getting hotter. Next slide, please. This is an image of observed U.S. precipitation change. Here in the map, you can see that regional differences are apparent. In the Northeast, Midwest, and Great Plains, you can see that they've all had increases, which is represented by the light green to dark green areas. And parts of the Southwest and Southeast have all had decreases, which is shown by the white, tan, and brown areas of the map. Next slide, please. We'll be looking at observed change in very heavy precipitation, and in this image, this is taking it one step further, and this shows the changes in very heavy precipitation. And what heavy precipitation events means is that we have more of it. So instead of getting a tiny sprinkle of precipitation, we are receiving a heavy downpour. And this slide shows very heavy precipitation from the years 1958 to 2012. Next slide, please. So this is my summary. There is a difference between weather and climate that everyone should understand. Climate focuses on air temperature and precipitation. The temperature of the Earth is increasing. As the temperature increases, evaporation increases. And as evaporation increases, precipitation also increases. And a main point to get from this is as climate changes, different areas get different amounts of precipitation. In the US, as discussed before, the Midwest, Great Plains, and Northeast regions have had decreases in precipitation, while in the US, the Southwest and Southeast regions have seen decreases in precipitation. Next slide, please. So what I wanted to do is talk about my research in my own words. So we all started off with one simple question: climate change and its effects on precipitation across the US. What we took away from this question is that it had so many links that formed it, such as climate change, heavy precipitation, or the demonstration of average annual rainfall, or even simple enough, just the relationship between precipitation and climate. This all demonstrated how everything is connected. See, in order for one action, it must be caused by another action, such as the domino effect. Everything is tied together. And I wanted to link this to soccer because I enjoy doing that. I enjoy playing it. And it kind of showed that if you kick a ball and it goes in the opposite direction that you were hoping, it could mess up the entire play, which shows that if one small action is different than expected, then you may miss the goal. And yeah, next slide, please. Here are my references. Next slide. Next slide. And then one more slide. I wanted to end it off by adding a picture of Eventually Everything Connects, because I feel like it brought together my entire presentation. Thank you, and if you have any questions, you may ask them now.
Thank you, Maddie. That was really interesting. It's fascinating how climate change really has an effect on us. So all of those presentations were great, and now I'm going to share some of my thoughts about the project and remote learning. I really thought remote learning was organized in an amazing way because everything was really direct and I could understand it easily. And this was really the first time we put together a slideshow like this, or a research project by ourselves with limited guidelines. And it was great to really have an interest in what we were learning about because we got to pick our topics. So one thing that was easy for me was we were working with data and numbers. So as an analytical person, I was able to better understand and organize my presentation. But one thing that was difficult for me was the lack of immediate feedback because we were messaging our teachers online. But two things that Ms. Gorman did to help us with that was, number one, providing us with a communication log, which was a continuous string of direct messages back and forth that gave us a response quickly and efficiently, as well as providing weekly office hour meetings, which were meetings via Google Meet or Zoom, so we could get live feedback from our teachers and classmates. And lastly, we were able to mimic the work of professionals to produce a result that was neat and clean and professional looking. Next slide. So now I can go back to Ms. Gorman.
Okay, so I could spend 5 minutes just saying how wonderful all these students are. And Trinity, thank you for that wonderful job of moderating. I've seen adults that can't do it quite as well. So I'm really pleased with everybody. But in the interest of time, I want to go right back into the reflection project findings. And I appreciate those of you who have stuck with us, even though I understand that some people had to leave. That's not a problem. So this is something that I'd want you to take back to your teachers or to the educators that you work with, because it's important that they understand how education in general, and especially remote learning, can have a very, very big effect. So how would students deal with a challenging long-term research project? Well, what's interesting is that if I were to give this normal grades, we had a strange set of grades at our school for the last trimester. But out of 90 students, 82 completed the project on their own. Okay, there were 8 who did not do anything. But those same 8 students, when I had them in school, didn't do anything either. So it's not that I would expect them. Now, Oh, hang on. I just saw Donna. Donna, I will make sure that the research packet, I know I'm not supposed to answer, but I just saw this come up and here's my ADD coming in. I will make sure my research packet is available to you so that you can see the steps that the students had to take. Anyway, getting back. So 80 out of 82 students that did the project, 77% received an A or a B. So anywhere, let's say from an 80 to 100. And there were some students who did receive 100. 15% received a C and 8% received below a C. So I think that speaks volumes for itself that the students were absolutely able to accomplish this. We don't give our students enough credit. We try to always do everything for them. We try to be such friendly, wonderful, kumbaya type teachers, and that's not always the best way to do this. Sometimes you want to go ahead and push them and let them find their limits, and they can do amazing things. What topics would they choose? Now, this is really interesting. Mr. Moore, wonderful Mr. Moore, has tried for years to convince me that there's only two real types of STEM, that there's GeoSTEM, and then there's the STEM that's in the medical field, like biomedical and health. Well, on their own, these children, when they had to pick the topics, they either concentrated on geo projects or they concentrated on health and biomedical. And it was really interesting to me because they all talked about, some talked about biology, some talked about chemistry, some talked about some physics type things, but it really split into those two categories. And I think that would be something interesting that we could all pursue. Could students add a layer to their critical thinking? Some could, some couldn't. And one thing you'll notice is that the students made some mistakes when they gave their presentations today, which is fine, you know, because they get nervous, they say something perhaps, but this is something that shows how hard it is for teachers to teach things like taking a broad research project, putting it into a concise story, like you guys said in the chat box. It takes time and effort on the teacher's part, and teachers should not be afraid of tackling something like this over and over and over again, even though it's difficult for students, because the more they do it, the better they become at it. And these are all 21st century workforce skills that really need to be, and not even workforce skills, they're just skills that really need to be emphasized in the classroom. So they had trouble adding that human connection, some of them. They just wanted to do a research project on one topic, but they were able to at least increase their critical thinking. Okay, what would be the reaction to presenting the research live using Google Slides via Google Meet? It was an experience that I think all students should have. And even if you are in the classroom with your students, I think when you ask them to present a topic like this, you should put a student off somewhere in maybe the library, the media center, maybe a computer lab, maybe even a back room, and have them present on the computer, because it changes the way that you learn how to present when you don't have a live audience there. And this is something that we see now, we do all the time now remotely. And so it was great. It was a great experience. They did a great job. They were nervous, but each student had a 15-minute slot and they had to give their presentation, and I gave their critique right on the spot. Should I, meaning Vicky, pursue turning this into a comprehensive STEM exercise for future students? Absolutely. And I suggest this to everyone. And like I said, I will send the research packet out so you can see, and I'll put it in, it's a Google Doc so that you can change it. I won't leave it in PDF. But the best way, and I'm preaching to the choir here, hallelujah. The best way to turn this into a comprehensive STEM exercise is to incorporate satellites, satellite imagery, because the thing that students have the hardest time with is analyzing images and being able to read graphs, images, any sort of data. I would include a data literacy component to this. And I would definitely include some sort of STEM exercise as far as the engineering part of the STEM exercise. In like, they could make a solar shield for a satellite to keep the degrees down on the satellite. They could, if they were in high school, they could do more of the CubeSat challenge like John was talking about. They could simply build earthquake resistant buildings, but tie it back into their research rather than just have, oh, we're going to build a robot today. And there's nothing against robots, and I love my robotics people, but it needs to be all tied in together. So we're using the S, T, E, and M. Using graphs, having students figure out graphs, all that stuff. Anyway, so the bottom line is, I am going to do this again. I am going to incorporate something called the Earth System Science Initiative. And if you guys look that up, you'll see 5 columns that were designed by Earth scientists, the Earth System Science Initiative. And I'm going to use that along with the spheres to have children or students think of their topics, and then incorporate satellite imagery. Right now I'm in the middle of making satellite lessons, individual remote learning satellite lessons, so students can do it on their own. And I'm going to keep the presentation portion. Because I probably won't see my students at the beginning of the year, I will take this slowly so not to inundate them at the beginning when they're still essentially 6th graders, but then take them through the year and have them grow and grow. So that's it for me, John. If you want to take it over. And Tracy, just a quick thing about data literacy. I'm working with a group of people out of DC called Resource Watch, and we just made a 3-part data literacy. I'm still in the middle, not the middle, but I'm finishing up teacher's notes for it. I'll send you the link for that as well, because it's a program that kids could do at home during remote learning. And it's data literacy by the people who take data, and that's their job, and show it in graphs and images and that sort of thing. But they're called Resource Watch. It's an excellent, excellent resource. Yep, and my NASA data for lessons and data sets, absolutely. We'll use everything that's out there. I don't, I create my own things, but I also don't believe in reinventing the wheel. And I know John doesn't either. And yeah. Oh, good. Peter, thank you for that. I'm excited. All right. Thanks, guys. Go ahead, John.
Okay, so just to wrap things up, thanks to everybody for hanging in here a little extra time.
John?
Yes, ma'am.
I would like to give Owen a chance to answer that one question. If he can remember the question he got cut off at.
Sure, go ahead, Owen. It's all yours.
So a way to promote the ocean to being clean is, well, there's some ways of doing that are like big, like making healthy sunscreen for the ocean, which would take a lot. But just a simple throw, if you see something on the beach and it's a like Gatorade bottle or something, throw it in the recycling, not the trash. Because most likely in the trash, it's going to end up in the ocean.
Thank you, Owen.
Welcome.
Okay, John.
Okay, so just to wrap up, as I was saying, thanks for hanging in there with us. And I think one of the reasons we wanted to do this is Vicky and I were talking and see what can happen when we were all kind of surprised back in March that amazing things can happen. And I want to thank you students for doing a great job. We're kind of suffering along with you in how we continue education, and who knows what September will bring. But for now, for this group particularly, we want to keep emphasizing the use of satellites. And one thing I've learned in my old age will say is that the time to institute change is when change is going on. So people are not sure what the next step is in many platforms. And we're about 40, maybe even 50 years behind getting satellite imagery and technology into the classrooms. And we just saw a clear demonstration of what students are capable of doing and working on the research and looking forward towards next year of looking at incorporating all that satellite imagery too. So thank each one of you for what you do. And if you're not on the satellite education team already, please contact me and you will be. That group is a group of experts that we're looking at collaborating together and developing this path forward. So thanks to Vicky and your students again, and thank you to all of you. And we can end this session now and have a good evening. Thank you.
Thank you, everyone. So great.
Thank you.